All right, recording in progress. Share the screen. All right, so all we have left is 2.5. So I have 2 days to do that. In reality, I have 3 days to do that. I can continue on to Thursday if necessary. And our exam is this coming Friday. And so reminders about the test. So you have to show up on the Zoom call on Friday. That's mandatory. Okay, so again, the only days where you must show up for the Zoom call is exam days. So, optional, optional, optional. Today is optional. You can watch the video later, but you must show up for the exam. And all of these are optional, 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 but you have to show up for the exam and so on. Okay, and again, now that you've already seen one exam, they're all similar. So you're responsible for chapter 2 material. This is all that is. Okay, and hate to disappoint you, I totally messed up on the homework assignment. Originally it was 1 to 6 all, 17 to 39. It should be 7 to 39. So that's more problems. Okay, so the bad news is the homework got increased, but the good news is I'm probably going to end up doing a lot of these problems anyway, as you already know the pattern. Okay, so when I say you have to submit at least 70% of the homework, that's true, but on the other hand, that's kind of a joke because I end up doing quite a bit of that, sometimes even 70% of the homework, in which case all you have to do is copy it and go from there. Yes.
Professor, I already did 2.5, so I'm going to put a little note on top, and my 7 through 15 or 7 through 16, sure. I guess, will
That's
be
okay.
At the end, okay?
Yeah, just attach it to the end. That's fine.
Okay.
Yeah, so sorry about that. No worries. You can change the order as necessary. Okay, so one more time, 2.5, 7 to 39, not 17 to 39. So there's 5 more problems? 7, 9, 11, 13, 15, 5 more problems. But anyway, I'm going to end up doing quite a few of them anyway. All right, so as soon as class is over on Thursday, you may start submitting the homework. Don't give me the homework now. If you already have it, great, but I don't want it too early. But as soon as class is over on Thursday, you can start giving me the homework. Okay, so Friday, everybody must show up to the Zoom call for the exam. I'll take attendance, not by calling your name. I'll just look at the participant list, of course. And have your camera on, the true background. Don't have behind you the Golden Gate Bridge or, outer space or something like that. And keep yourself muted. And if you have any questions during the test, just bring it up during the chat. Okay. And so I'll close the Zoom as normal, which is 10 o'clock. Then you have 5 minutes to go click, 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 or scan on your cell phone and then email to me. And then you have until 10:30, another half an hour to submit the homework. But again, if you want to submit the homework early, right after class Thursday, get it over with, then you don't have to worry about submitting it, because I know sometimes it takes a while to get all your pages. You have 10 pages, 12 pages, 20 pages, I don't know, of your homework, right? So that takes a lot longer to do. Okay. All right, so starting our last section, 2.5. Again, the homework is now 1 to 6 all, 7 to 39 odd. Okay, and it's on inverse functions. We're doing inverse functions.
When you start going through it, could you just through the homework, or I'll wait till you start it.
Okay, yeah, I might answer some of the questions as we go along anyway. But yeah, so 2.5, page 111 is where inverse functions start. Okay, so I'm going to give my own spiel on how to do inverse functions. And so forth. Okay, so inverse functions, again, ignore any dates that are here. All right, so inverse functions. First, we have to talk about something called one-to-one functions. In fact, we're going to spend most of our time today on one-to-one functions. And my abbreviation for one-to-one is 1-1 because it's too cumbersome to keep writing ONE-TO-ONE. So one-to-one like this. All right, so first we call a function is a relation such that for every input X in the domain, there corresponds a unique output Y in the range. Okay, one X can only give me one possible Y. Okay, and some simple examples are f of X equals X squared, okay, which happens to be an even function. We know what it looks like, it's a parabola. F of X equals X cubed, which happens to look like this. It's an odd function, has origin symmetry. x squared has y-axis symmetry. Easy way I think of a function is 1x, 1y. Okay, 1x can only give you one possible y value. So if you give me any number, if I plug it in here, I'm not going to come out with two possible numbers, right? If I plug in 7, I'm coming back with 49 and nothing else. If I plug in -3, I'm coming back with 9 and no other number. Likewise here, right? If I plug in 3 cubed is 27, I'm not going to also say 28 or 26. If I plug in -2, -2 cubed is -8. That's the only number it's going to be. It's not going to be any other number. 1x gives me 1y. And you might recall functions pass the vertical line test. Okay, if I draw vertical lines drawn anywhere, it'll touch the graph in at most one point. Okay, so I draw vertical lines. Both of these seem to pass the vertical line test. It's only going to touch the graph at one point. Okay. And here's one more example. F of x equals 1 over x, happens to be an odd function. And it looks like that, like that. The domain is all real numbers except for the set consisting of 0. I cannot take the reciprocal of 0. Okay. And of course, we know it passes the vertical line test. 1x gives me only 1y. So if you tell me 3, the function is going to give me 1/3. It's not going to give me any other number. If you give me -2/3, I'm coming back with -3/2 and no other number. I'm not going to come back with two numbers. So 1x gives me only 1y. Right. Now, special kind of functions, one-to-one function. And my abbreviation for one-to-one is 1-1, like this. Okay, so what is a one-to-one function? Well, first of all, it's a function, right? So from laws of language, I guess, one-to-one modifies function, right? So first and foremost, it is a function. So whatever this one-to-one function stuff is, it does fit the category of a function. So it still has to be true that 1x gives me 1y. It still has to pass the vertical line test and so on. Okay. Now I am modifying function. Right? So I guess one-to-one can be considered an adjective, right? That modifies this noun of a function. So it's a special kind of a function. So first of all, it is a function, right? It does pass the vertical line test. 1x gives me only 1y. So what's the big deal about this one-to-one function stuff? Okay, one-to-one function has a property such that for each output y in the range, there corresponds a unique input x in a domain, which means not only does 1x give me 1y, property of functions, but it's also true that 1y corresponds to only 1x. Okay, so any y in a domain originated from only 1x. Okay. So what are you talking about, right? So what do you mean by that? So let me give you some examples. So we've already seen that y equals x squared, y equals x cubed, they're functions. Okay. Let's look a little deeper into x squared. Okay. I claim this is not one-to-one because first I have a couple points. 2, 4, right? If I plug in 2, I get 4. What happens if I plug in -2? -2 squared, also 4. Still a function. We're saying it's not one-to-one because y equals 4 has two possible values of x, -2 and +2. Okay? So for this weird one-to-one function, not only is it true that 1x gives me only 1y, it's also true that 1y came from only one possible x. Okay. In this case, suppose I say y equals 4. By the way, again, I say y. You say, where's y? I don't see y. Remember, y is the same as f of x, right? You can pretend this is y. So suppose I say y is 4. There's two possible values for x, right? 2 and -2. Therefore, by definition, we do not have a one-to-one function because any y could only have come from 1x if it's one-to-one. But if I say y is 4, there's two possible values of x, 2 and -2. However, for x cubed, I claim it is a one-to-one function for every y, there's a unique x. Okay, so let's pretend I say y is 8. 8 equals x cubed. What can x be? For real numbers, it can only be 2, nothing else. Just 2, not negative 2, right? Negative 2 cubed does not give me 8, it gives me negative 8. Suppose I say y is 1. Careful, I'm not plugging in for x now, I'm plugging in for y. Suppose 1 equals x cubed, then what does x have to be? Well, x has to be 1 for real numbers. That's all we can get. 0, 0. If y is 0, x has to be 0, nothing else. How about y is negative 1? So I'm really saying what number cubed, what number times itself gives me negative 1. Only negative 1. Negative 1 and nothing else, right? There's no other number that's going to work. So this x cubed is a one-to-one function because for every y, there is a unique x also. It could have only come from one possible x. Okay? And as you can probably guess from the way I drew this, okay, we have a vertical line test, we have a horizontal line test. Okay? So for one-to-one functions, a function is one-to-one if it passes the horizontal line test. That is, a horizontal line is drawn anywhere but touch the graph in at most one point. Okay? So first of all, one-to-one function, it's already a function. Okay? So function, noun, one-to-one, adjective, I suppose, right? Modifies function, special kind of function. So these are still functions, right? We've gotten past the function. Both of these pass the vertical line test. But now we can use the horizontal line test to determine one-to-one or not one-to-one. Okay, now let's look at x squared, right? It does not pass the horizontal line test. If I draw a horizontal line, it'll touch 2 points, which is another way of saying that if I say y is 4, I have 2 possible values for x, 2 and negative 2. However, that does not happen for x cubed. If I draw a horizontal line anywhere, it's only going to touch at 1 point at most, right? So there, or there, and there. Interpretation is, if you tell me y is 8, x has to be 2 and nothing else. If you tell me y is negative 1, then I'm going to say x is negative 1, but nothing else. So that gives me a one-to-one function. That's not true here. If I say y is 9, you say, oh, x can be 3 or negative 3, plus or minus 3. So not one-to-one. Okay. So horizontal line test for one-to-one functions. A function is one-to-one if it passes the horizontal line test. That is, horizontal lines drawn anywhere touch the graph in at most 1 point. Okay. Here's another example of y equals square root of x. And you should be somewhat familiar with y equals square root of x. By the way, you can always do this with graphs. You should not panic and say, oh, I forgot what does a graph look like. Just plug in points, right? So if me, myself, say, I totally forgot what the square root function looked like. Just try some numbers, right? I plug in 0. Square root of 0, 0, 0, 0. Square root of 1, 1. I don't like square root of 2 or 3. How about 4? Square root of 4, 2, right? Then I say, oh, it's curving this way. So there's the graph of y equals square root of x. Okay, so the graph looks like that. You can see it does pass the vertical line test, but it also passes the horizontal line test. So y equals radical x is a one-to-one function, right? Based on just the graph. So you can use the graph to determine one-to-oneness, I suppose you can say it. Do you have a one-to-one function, or do you not have a one-to-one function? All right, so with that in mind, we can start doing some of the problems. Let's see, we had to go up to what, 39? Okay, so for those of you that don't have the book and aren't getting it, page 119. 1 through 6. I think you can see everything. Yeah, you can see pretty much everything on that page. And then over here, whoops. 18. And we had to go up to 39, I think. And then some problems at the bottom there. And there we go. Okay. So 1 through 6, we can knock them all off now. Determine if the function whose graph is given is 1 to 1. So 1, 2, 3, 4, 5, 6. Get ready to write down the correct answer immediately, and we're done. And by the way, for this kind of problem, if I give you something like this on a test, I might ask you, why is it 1 to 1 or not 1 to 1? So it's not just yes or no. You could flip a coin and get it right 50% of the time, but say this is 1 to 1 because, right? Or this is not 1 to 1 because. Okay, so 1, 2, 3, 4, 5, 6, it's all ALL, okay, which means you don't have even answers in the back of the book. But again, don't panic. We're going to do them all. A reminder, you notice most of the homework is from odds because you have odd answers. And when there's evens, I wanted to include the evens, but more than likely I end up doing most of the evens anyway. Okay, so 1, 2, 3, 4, 5, 6. By the way, before I go on, I'm just noticing, determine if the function whose graph is, okay, they're already telling you these are functions, 1 through 6. Do you agree? All of these are functions. All of them pass the, what test? The vertical line test, right? So if I draw a vertical line anywhere for 1, 2, 3, 4, 5, 6, it looks like it's going to touch at only one point, right? But for a 1-to-1 function, we also have to pass the horizontal line test. So if I give you a question on the exam, say, is this 1-to-1? Then say why, right? Say, okay, it passes or it does not pass the horizontal line test. That's all. So we can knock them off pretty easily. So question 1. Okay, question 1, it is or is not a 1-to-1 function. So number 1 is a yes, it is 1-to-1. It does pass the horizontal line test. Okay. Number 2, I think the idea behind number 2 is that this is exactly horizontal. Okay, it looks just like that. So number 2 is not 1-to-1 because if I draw a horizontal line right here, it's going to touch at all these points, right? So number 2 is a no. Okay, how about number 3? No, right? If I draw a horizontal line right there, looks like it touches at 1, 2, 3 points. Okay. And how about 4? There are some horizontal lines. 4 is yes, it is 1-to-1. And 5 and 6 should be easy. 5, it is or is not 1-to-1 based on where I've put down my ruler. No. In fact, 5 kind of looks like y equals x squared. Okay, so it's a no, it does not pass the horizontal line test. I can draw a horizontal line which touches 2 points. And how about number 6, right? Looks like a no. Okay, so that wasn't too bad, right? Okay, then how do I do 7 through 15? Whatnot? Yeah, whoops. Determine if the graph is 1-to-1, and I'll just go through them all right now anyway. For these, it's basically, do you recognize what the graph looks like? Okay, determine if the graph is 1-to-1. So they don't give me this, but can you come up with this, or mentally, can you think of what this thing might look like, right? Okay, 7. What do you think that looks like? Hint, it looks like mx plus b. Crudely, it's a line with a positive slope. So it's going to look something like that, right? So do you think it's 1-to-1? Yes, it is. So 7. I didn't draw it exactly. I don't have to. Its slope is positive. The B is negative. So very crude graph looks something like that. So does this straight line look like it's 1 to 1? Yes, it is. So 1 to 1. 9. Okay. You don't need an exact graph, but think of that. It's basically your absolute value function, right? Do you recall what its absolute value function looked like? V shape. And it's translated. You know, it's what, 1 to the right and 1 up. It's still V shape. So if you have a V shape, does it pass the horizontal line test? No, it will not, right? So very crudely, here's my absolute value function in red, absolute value of X. And then what did we do? Let's see, over 1 and up 1, 1 to the right and 1 up. So it ends up going like this, the one that I have in green. And it's not 1 to 1. Okay, so what did I do there? This was indicating my horizontal line, right? I went like that and said, oh, it does not pass the horizontal line test. So therefore, number 9 is not 1 to 1. Okay, 11, x to the 4th plus 1. Now, x to the 4th is kind of like x squared. We don't call it a parabola, but it still opens up. It's still an even function. You can tell there's an even exponent. Let's see, even functions have symmetry with respect to the y-axis. So it's still going to be U-shaped. And what does that plus 1 do? 1 up. So in a very crude graph of 11 is something like this. And again, I say it's not 1 to 1. Okay. So I can find a y value that has 2 possible values of x. In fact, I think I can do that pretty easily. So the problem's finished. It is not 1 to 1. But let me speculate. Yeah, suppose I say y is equal to 2. Suppose behind my finger is 2. I'll write it out. 2 equals x to the 4th plus 1. Subtract 1. 1 equals x to the 4th. 1 equals x to the 4th. So can you think of what numbers, plural, would make that true? 1 works, but also -1, right? So for a particular value of y, 2, I have 2 possible values of x, 1 and -1, which means the function is not 1 to 1. It's still a function. It still passes the what test? It's still going to pass the vertical line test, but it's not going to pass the horizontal line test. Okay. Right. 13 is one of those piecewise defined functions. There's no way I can do this unless I actually graph it to see what's happening. Okay, so f of x is this funny thing, but you should know something about them. What's the shape of that?
Yeah, when I just took one look at it and I knew it's 1/2 of a hyperbola basically, and then the left side is when x is less than 0. It starts at -2 and it goes down. So that's how I figured out that it had to be 1 to 1. You think about it,
Okay,
right?
yeah, it's linear. This is what I know. This is parabolic, as you said, only for x greater than or equal to 0. So U-shaped, except only half of it, right? And this is a straight line for x is less than 0. Okay, so the quickie graph. So 2x squared, x is greater than or equal to 0. That includes 0. So this one touches the origin, 0, 0. And then it shoots up. I don't have to be very accurate. I know it goes like that. And yes, I know this one is a line. with a b, y-intercept of -2, slope is 1, that's going up at a 45-degree angle. But I don't go on this side, I only go on this side because it's only for x less than 0. And open circle, because when x is 0, I obey this rule, not this rule. So 0, -2 has an open circle. So it looks like that. All right, so the function looks like this. And does this thing pass the horizontal line test? Yes, it seems to. So I do have a one-to-one function. All right, so that takes care of everything up to 13, essentially. I think I've almost literally done them all. So now let's continue on with inverse functions. Then I'm almost done for the day. Okay, one-to-one functions have something called inverse functions. So if a function is one-to-one, it has something called an inverse function. If a function is not one-to-one, it does not have an inverse function. It's the first notation. But f with a -1, almost like an exponent, but it's not really an exponent, parentheses x, we say f inverse of x, meaning that's the way you say it. This is called the inverse function. So we say f inverse of x, even though it looks like f with a -1 exponent and an x, but it does not necessarily mean exponent of -1. Most of the time, it doesn't mean that. We read it as f inverse of x. So what is this weird f inverse stuff? Whoops. Okay, f inverse of x has a property that f composed of f inverse of x gives you the original x. And likewise, f inverse of f of x is equal to x. If you compose a function with its inverse, you get back to the original. Now, we just spent a whole section on composition of functions, the f of g and g of f, the Fogg and Goff stuff, right? F of g of x and g of f of x. And then in general, we said, if you do the Fogg and you do the Goff, you don't necessarily get the same thing, right? For this inverse function, you do get the same thing. And even more specifically, if you do f of f inverse, you get back the original x. And if you switch it around, the f inverse of f, you also get back the original x. So think of f inverse as the g, and you're doing the Fogg and the Goff stuff. The Fogg and the Goff are exactly equal. And not only that, we know what the answer comes out to be. It comes out to be the same as the original x. So think of this as g from the previous section, and that's g. So it's like Fogg of x and Goff of x. But more specifically, the thing you get back is your original x. Okay. Think of f inverse as the undo function. You know how you undo a function? You undo operations on your computer all the time, right? Or you do something, you say, oop, I made a mistake. Can I get back to where I just was? And sometimes I'm doing something on the computer and I accidentally do something wrong. Oh, can I go back? Or there's a shortcut, Control Z, that I do, right? If some of you know Control Z. So, oh, I did an operation. Oh, I didn't really want to do that. How do I get back to where I just was? I do a Control Z or undo, right? The undo function of f. Okay. So think of f inverse as the undo function of f. How do I get this inverse function? You switch every occurrence of x comma y to y comma x. So if x comma y is an f, switch it around. Okay. Y comma x is in f inverse. Okay. So a simple example is if the point 3 comma 5 is an f, then 5 comma 3 is an f inverse. So you just simply switch around the x and the y. What that also means is this, and if you want to put this on your cheat sheet, you may. The domain of f becomes the range of f inverse and vice versa. And that makes perfectly good sense, right? Since you're switching around the x's and y's, well, if you switch around the x and y's, the domain of one simply just becomes the range of the other and vice versa. Okay, so think of it as the undo function. Okay, just for reinforcement, I'll show you some of the stuff that the book has. Okay, so on page 113, now, page 112, the author gives you this definition of one-to-one. I don't really like it so much because I think it's confusing the students. It's a true statement, but I don't like the way they put it. So I would say don't even look at it if you don't want to. Okay. This one you definitely want, or I've sort of already given it to you. But if you want it in the text, it's on page 113. A function is one-to-one precisely when every horizontal line intersects its graph at most once. Okay. So x cubed is one-to-one, 1/x is one-to-one, but not one-to-one are the v-shaped absolute value function or f of x equals x squared, right? Not one-to-one. Okay, inverse function, excuse me. Okay, inverse function. So what's all this saying? Okay, the notation is f with a -1, we say f inverse of x. Okay, and don't worry about all this domain and range stuff. We already know the domain of one becomes the range of the other. F inverse of f of x is equal to x. Okay. Here are some properties of the inverse function. So do I have to write all this down? I don't think so. I've given you everything you need. The inverse is unique, meaning there's not more than one inverse. Well, that's kind of obvious for us. We don't have to worry about that. This one I've sort of already said. The domain of one becomes the range of the other. They were just more specific there, but I sort of already had this. The domain of f becomes the range of f inverse and vice versa, because all you're doing is switching around the x and y's. The statement f of x equals y is equivalent to f inverse of y equals x. These two mean the same thing. So for one-to-one function, if you put a function here, we write it as f inverse. So f inverse of y is equal to x. And this last property I've just mentioned to you already, the fog and the Goff stuff, right? Imagine f is the g. If you do g of f of x, you get the same thing as f of g of x, and specifically, you get back the original. Okay. All right. Yeah. (15, 17). Sketch the graph of the inverse of each function. How can you possibly sketch the inverse? Okay. One way to do it is just take some key points and switch them around. Okay. What is this point right here? Like I'll just write in my book. I'm going to corrupt the book, but that's okay.
I just like guesstimated because 15 is kind of complicated, you know, like I put like 1 point is like 1.8 because it's like at 1, it's not exactly at, you know,
it's not exactly, yeah, you can just guesstimate.
Okay.
I'm calling this 0, -4. Okay, this one I'm going to call 1, -1. This one, well, about 2.50. So what am I going to do for the inverse? 0, -4, switch it around, -4, 0. And the dumb thing I think is they don't let me go out that far, so I've got to make it go farther. So I guess I'll just come out like that. So -4, 0. One, -1, -1, 1. These two switch around. 2.50, so 0, 2.5. These two I switch around. Okay. And so on. I mean, it's hard to get it exactly, but if you kind of get the idea, especially if you show me the idea of switching the points, then you have it. You just kind of connect the dots. You can make it more accurate, of course, by picking more points. This is my guesstimate for F inverse. This one, 17. Okay, so that's what, 1, 0? And oh boy, what do I want to say? 3, 1 maybe? Over here it just drops down. Maybe that's all I feel like doing. So 0, 1, 1, 0. 3, 1, 1, 3. And this drops like that, so this one's going to drop like that. So maybe we'll just like so. So here's my F inverse. Okay, we'll get this later on, but you might recall this from your intermediate algebra. We'll do more of that. Recognize these graphs? This is actually an exponential function. We'll get that in, I believe, chapter 5. This is a log function, logarithm function, which is the inverse of the exponential function. Okay. All right, folks, I'm just about done for today. I'll just tell you where we're headed. So we are done up to 17. Again, I think I've literally done, yeah, I believe I've literally done every single problem. So again, when I say you have to do at least 70% of the homework, it's kind of a joke because I end up doing sometimes 70% or even 100% of the homework, in which case all you got to do is just copy what we did in class in terms of turning in the homework. Okay, I'll just mention where I'm headed tomorrow for 19 through 23. F of x equals blah, blah, blah. Okay, one thing to keep in mind, when it says f of x, it's the same as what letter? It's the same as y. So pretend it says y equals blah, blah, blah. And it's got this f with a -1 stuff. So you say, how do I do that? Okay, you should already know what it means to do f of 2. Okay. So suppose I change the problem 19, say f of 2. You say, oh yeah, plug in 2. Right? F of 0, plug in 0. F of 1, plug in 1, right? But it's not f of 2, it's f inverse of 2. So it must not be true that I'm plugging in 2 here or 0 here, because that would be f of 2, and it wouldn't make sense for f of 2 and f inverse of 2 to be the same thing, right? So the logic I would say is, you know you're not plugging in 2 here, because we already know what that means, that's f of 2. So I must be plugging in 2 somewhere else. What else is there? Well, I'm not plugging in for x, therefore I must be plugging in for y. That's the only other letter. And again, you say, where's y? I don't see any y. All of these mean y. So when you're working problems out, call each of these y. Y equals blah, blah, blah. Y equals blah, blah, blah. And then plug in not for x, but you plug in for y, and then you end up solving for x. Okay, and I'll show you those starting tomorrow. All right, but that's as much as I was going to do for today. And let me stop the share and see if there's anything in the chat. I don't see anything in the chat for now. Okay, so anybody want to ask a question? And if not, we're done for the day, folks. So any other questions, please? Okay, I don't hear anything or see anything. So that's it for today, folks. All right, so have a good day. And we'll see you next time.
Thank you.
Thank you. Bye, everybody. Bye.